Hey everybody, you're listening to the Simple Electronics podcast. I'm your host, Simple Electronics, and with me I have a special guest today, Dave Bodnar. Dave, how are you?
I'm doing well, thank you.
Did I pronounce the name properly?
Yes, Dave Bodnar works fine.
Excellent. Can you introduce yourself to the viewers a little bit? Because I've been watching your YouTube channel for a little while, and I'm hoping that the viewers that haven't checked you out will check you out after this. But until then, who are you?
Who am I? Well, I'm a retired teacher. I taught math and science primarily for 16 or 17 years, and then spent the second half of my career, another 16 or 17 years, running the technology department in a school district, fairly large one. And I've enjoyed teaching and presenting things all my life. And when I retired, I really delved in. This was about 16, 17 years ago when I retired. And I did retire young. I started documenting the things that I built. I've always been an electronics hobbyist. From the time I was a young child, I used to take things apart all the time and try to figure out how they were working. Anyway, I designed a computer-controlled train back in 2004. And that was the first thing that I documented on a web page. It's still there. If you go to davebodnar.com or trainelectronics.com, you'll find something called the robot train in the garden. It was a garden railroad locomotive. Anyway, I had a lot of fun with that, and I got hooked up with an online magazine for large-scale railroad enthusiasts, and I wrote articles for that magazine for, gracious, I bet 10 years until it went away. And then I just continued, and I found that YouTube is a good way to add to the web pages that I created about various projects. So I started doing videos. I think the first video was 10 or 11 years ago. And I've done 100 and some since then. Whenever something strikes me as interesting, I'll try to document it for others. Anyway, that's who I am.
Interesting I think is a little bit of an understatement, because I think pretty much everyone who's listening has an idea a little bit about electronics, at least that's kind of the point, to draw them in. But I've seen you sort of use things in a different and novel way, which I wouldn't have thought of, that's for sure, and probably a lot of my viewers wouldn't have thought of. The one thing that comes to mind is you're using an audio amplifier to signal an LED to turn on to make it look like lightning. Can you speak about that a little bit?
Oh, yeah, one of my favorite projects. And in the background, I don't know if you can hear it or not, there's a clock chiming. It's one of my other projects. I built a clock that chimes out the hours and does a number of different things. Anyway, back to thunder and lightning. I was trying to come up with a way not to synchronize thunder and lightning, but to synchronize flashing lights and an explosion. We were doing a G-scale train layout, and we wanted to have a mine explosion where you would hear somebody say, clear the area, blasting in 10 seconds. And then at that 10-second point, you would set off a couple of electronic flashes from disposable cameras and have the explosion sound synchronized with it and flashing at kind of the same rate. Anyway, I took the output of an audio amp from a little thing called a DF player, which is an MP3 player that interfaces nicely with microcontrollers, and used that to trigger a high-power transistor, a MOSFET, that was connected to some really bright LEDs. And the blasting in 10 seconds worked out beautifully, and I took that some months later and decided it would be kind of cool to have thunder and lightning, and that worked out even better, because thunder, of course, has a whole lot of different amplitude sounds coming out of it, and you get a very, very nice effect from the LEDs. And of course, coincidentally, LEDs got really bright about the time I was doing that. So I was able to take some 50-watt equivalent LED bulbs and flash those.
Oh, and just at its core, when you think about it, the thunder is the noise that the lightning makes. So it makes sense that you would want to flash the LED at the same sort of amplitude that you'd be hearing the thunder, right? They're both related to each other. They just have a delay depending on how far away you are from the actual lightning, correct?
Well, that brings up an interesting point. Yes, you're correct. And I did feed the output of the audio into an analog input on the microcontroller so that the louder it was, the higher the number that came in. And I set some thresholds. If it's below this particular point, don't flash the light. If it's above this threshold, go ahead. But here was the challenge. I initially designed this project, worked really well, but it was as though the thunder and the lightning were both occurring in your backyard. And that doesn't happen all that often, at least hopefully. You don't want thunder hitting too close. And somebody said to me, why don't we have it set up so you could have the lightning and then 5 seconds later, a mile away, let's say, you would hear the thunder. And my first reaction was the microcontrollers I was dealing with, at that time it was either a PIC microcontroller or an Arduino, they just don't have enough power to delay something. And I came up with the idea, and this is documented both on my webpage and on a YouTube video. Take the stereo soundtrack that the sound card could use, because it will do left and right channel. Use one side of it to light up the LED. The other side of it you would delay and play the thunder. And that worked out like a champ. All you have to do in Audacity is create a stereo channel, pair of stereo channels, separated in time by whatever length of time you want to have the thunder come after the lightning. But I was quite pleased that I figured that out and got it to work. And any number of people have built that project and written to me saying, hey, it works really well.
It works incredibly well. And like looking back on it now, I look at the video and I'm like, yeah, that's so obvious. Why didn't I think of that? But the truth is, it takes someone to sit down, take some time and be like, how do we solve this problem? And it was you did it. And I have to say the effect is incredibly convincing that if I ever built any scale scenery or anything like that, I would definitely be implementing something just like that, because the simplicity is so elegant. Like it took you once you had it figured out, it takes you all of 45 seconds to run your audio through a program like Audacity and delay one of the channels, and then you're done. So you can add hundreds of different thunder and lightning effects if you wanted to with the same concept, right?
Oh, yeah. And there are any number of things you can do with this, both in thunder and lightning and things like an explosion or what have you. And it's not just model railroad people that are doing this. There are not a lot of people that are really into the weather. And they've made clouds for their living room out of gray colored cotton. And they'll put the lights inside of the cotton clouds, and they'll, periodically play the thunder and lightning. It's kind of neat.
Yeah, that's brilliant. I've actually seen people make 3D printed versions of the Saturn V rocket, for example, and use similar concepts to do the sort of like the rocket fire inside of a cloud of cotton for the exhaust. So you can have a lamp which looks like it's Saturn V rocket taking off. And I mean, how much more inspirational can you get than a Saturn V taking off in your living room, right? It's incredible.
That would be incredible.
Yeah. So, but it doesn't end there, because you actually Arduino was kind of like a later addition to your channel. I see that your earlier videos are using another microcontroller. You were using a pickaxe for a while. Can you talk to that a little bit?
Oh, I can even go back further than that. In it must have been the early 90s. A microcontroller called the Basic Stamp came on the market from a company called Parallax. And I'm a ham radio operator, and I was reading one of the ham radio journals, and somebody wrote up an article that showed how you could take this little microcontroller, connect it to a radio and a touch-tone decoder, and by sending touch-tone, the noises that come out of a telephone when you're dialing, to it, you could activate a relay. And I just thought that was the greatest thing in the world. And that was the first project I ever did with a microcontroller. I'm thinking it was might have early 90s, could have been late 80s. And after that, I found the pickaxe. The pickaxe is and they're still around. It's a microcontroller used primarily in schools in Great Britain and Australia. It's a PIC microprocessor. PIC comes from a company called
Microchip now, I think.
There you go, Microchip, down in Phoenix or Chandler, Arizona. And they put a front end on it so that you can program the PIC just using a serial port or now a USB port. And it's pretty robust. I mean, I still use them occasionally, but I decided at one point that why should I be using the pickaxe, which sits on top of a PIC? Why not learn how to use the PIC? So I bought a program called PIC Basic Pro, a couple $100 for the programming software and the interface, but I did an awful lot of projects for many years using the PIC microprocessor, a whole bunch of different varieties. I still use them, but maybe 10 years ago, 8 years ago, I decided I should learn something about the Arduino because that was really the most popular worldwide processor. So I've been working with Arduino, again, of many different varieties for the better part of 10 years.
Yeah, Arduino is fantastic because I feel like what they've built, because I mean, it's nothing special. It's an Atmel microprocessor, and like you said, PIC existed for a long time, and enthusiasts were using Z80s and stuff long ago. So a microcontroller is nothing novel. What's novel is they seem to have standardized the form factor, they've standardized the environment, they've standardized libraries, and I believe that level of standardization and then open sourcing of the hardware and the software just allowed the commoner, like everyday people, to pick it up and use it. It's more beginner friendly than having to learn BASIC, for example, or like machine code. I find it's a little bit more accessible, and so people are less afraid of it, and I think that's what caused it to take off. Would you agree with that?
I think I would. There was a time when I encouraged people very strongly to use a pickaxe because the software was free, it was relatively well supported, relatively inexpensive, and I shifted away from that some years ago, probably 6 or 7 years ago, in the various seminars that I've done, and encouraged people to learn the Arduino. C is a much more, commonly used language. There's a phenomenal amount of support on the internet. I mean, if you have a problem, you just type in an error message and into Google, and you're going to find a couple of hundred people that have the same problem and give you some assistance, either by reading what they did or sending a question to a forum. You have to have some idea how to program, but it's not all that bad, and the tools are there to help you to learn it in relatively short order.
Absolutely. And I think that's the same kind of deal with the single board computers, because I own a couple Raspberry Pis and I own a couple Orange Pis, it's known as a knockoff, but I mean, it's entirely different because it has a all-winner HC system on chip. It's very different to the Raspberry Pi. But I'll tell you, if I run into a problem with the Raspberry Pi, the internet seems to be about 10% filled with just people using Raspberry Pis, whereas the Orange Pi, I have to go onto like specialty forums that really deal with that, and the traffic there is abysmal. So if I'm recommending a single board computer for somebody to buy, it'll be a Raspberry Pi every day of the week.
Yeah, coincidentally, I've been working with the Raspberry Pi ever since the first one came out. Let's put it that way. I think I bought it within a month of them being released to the general public. That was a microcontroller-based device that was meant, as I recall, one of their universities developed it, and they were sending them out to new students to see what they would do with them before they would start their college education. And boy, it was cheap, $35 as I recall for the first one that I bought. And right now you can get a Pi Zero for what, $5 plus shipping? I mean, it's unbelievable.
Yeah, if you're an American, here in Canada, I think the cheapest Pi Zero I can pick up must be in a package. We can't buy a Pi Zero by itself from any retailer that sells it in Canada. And I think the package with the shipping starts at about $45 or $50. So it really took away the kind of the hope I had for a $5 microcontroller. Thankfully, a fellow YouTuber called Another Maker, he lives in the States near a Micro Center, in fact. And last time he went to Micro Center, he picked me up a Raspberry Pi and shipped it to me, Pi Zero. And so I now have my hands on my first Pi Zero, and I'm actually excited to get started with that little thing.
Yeah, I've got a bunch of them. As I mentioned, I'm a ham radio operator, and there's a protocol for ham radio operators called DMR, and it allows me to use voice over IP into an interface that goes into a Pi Zero, and the whole thing winds up being about the size of 3 or 4 packs of chewing gum, and I can talk to people all over the world with it using voice over IP. And it's the center of that whole thing. The way that it operates is based on the Pi Zero.
That's incredible. Any technologies that will bring people of similar interests together, I think is just a net positive overall.
Well, yeah, and the thing that's most interesting about this, I'm a cyclist, and I ride pretty much every day. And weekdays I'll go out at 5 a.m. before traffic starts to peak up and ride out into the country. And I can carry this radio equipment with me. Again, being voice over IP, part of it uses a Wi-Fi connection through my phone. And I can chat with a group of people that I've gotten to know over the last couple of years, literally all over the U.S., just as though they were sitting next to me on another bike. I mean, the quality is phenomenal. So the technology has done some really neat things.
Absolutely. And I'm actually, I'm hopeful for the future, because if we have these Atmel chips on the Arduinos, which are now becoming, I don't know, like some of them are available, like say the AT Tiny 85, the little one, that thing's available for under $1 each. And I mean, it doesn't have as much computational power as an Uno or a Mega, but like it's literally under $1. You can do work for under $1. And as technology advances and the processes shrink, the nodes shrink, and the efficiencies go up, I look forward to seeing what kind of microchips we'll be able to get in 10 years for $1. You know, it seems limitless.
Well, yeah, Moore's law says it's going to double every 18 months, and that I see no reason why that wouldn't be true of these little devices. In terms of cost, still the most cost-effective bang for the buck is the PIC. You can get an 8 or 14-pin PIC for less than $1, and that has a lot more power and needs a lot less on the front end than the Atmel chips. I'm still very pleased with the way the PIC operates, and you know, one of my favorite projects was a flashing LED light set on my helmet. And this happened to be the cover story on Nuts and Bolts magazine a few years back. And what it does, instead of just flashing to let cars know that, hey, there's somebody coming, it flashes out the temperature. If the temperature is 65 degrees, it'll flash 6 times, pause, /5 times, and then it has a pause before it starts up again. So all my buddies know to look at my helmet to find out what the temperature is.
See, that's incredible. I use those kinds of examples when I teach my students, since I teach the automotive trade. I teach my students about microcontrollers and electrical and whatever, and I'm explaining to them that the computerization of cars, like cars becoming more and more electronic, is actually a net cost saving, because you're running fewer wires because you have fewer sort of direct, like circuits that are controlled directly by relays. So your signal doesn't have to go like from the driver to the front fuse box through a relay and then all the way back to where it needs to be controlled. But on top of that, the manufacturers can start differentiating their models by simply software. So for example, one vehicle will have the windows roll up and down with the switches as normal. The driver's window will have an auto up, auto down. But then on the next model, they can program both front windows to have auto up, auto down. And the next model up, they can do all 4 windows, for example. And that's all by flipping a couple bits in code, right? They just write in the code for all the modules. And the modules that get installed in the lower end cars, they just disable the features. And so I don't think it's necessarily a bad thing to go all electronics, but you do have to know how they work in order to diagnose them, at least in my trade.
Yeah, the interesting thing about the new Corvette, the C8, is it has a throttle, brake by wire, which bothered a lot of people. There is a linkage to the braking system, but primarily it's a potentiometer. When you put your foot down, it tells the system to crank up a pump and put pressure onto the fluid. But the reason they did that, which fascinated me, is if you happen to be in a racing situation and your brakes get so hot that you boil the brake fluid, most cars, standard car, will not stop because it's got gas in the lines. This thing, because you're telling a motor to put pressure on it, will continue to put pressure until the car stops.
Exactly, because the pump won't run out of stroke. It's a circular device.
Exactly.
Yeah, and then so some of the new Hondas, because I work at a Honda dealership, some of the new Hondas have full electric brakes. But it's funny because when you're pushing on that potentiometer, you're still pushing on a plunger in a master cylinder. It's just doing nothing. But if you sink your foot all the way to the firewall, that plunger will go and actually touch the piston and push the piston the rest of the way in. So you do have manual braking, but you have to go beyond the regular reach of the master cylinder's regular use. It's very interesting how they implemented that.
Yeah, that's exactly what the C8 Corvette does.
And it's crazy because you can look today at modern day Mercedes S-Class, for example, and they have so much electrical stuff on it, and it's really expensive to produce all these things. But that means that in 5 to 10 years, you're going to get those kind of electronic things on the base models, those high-end luxury cars or the high-end sports cars that have the really high demands, like a Corvette or a Mercedes. Those things, they pioneer all this technology, and then it boils down into the Sonics and the Civics and the Corollas eventually. It's very interesting stuff how technology kind of trickles down from one end to the other.
Yes, it is. And in our hobbies as well.
Oh yeah, 100%, right? Again, if we didn't have high-end optical processing from, let's say, the auto manufacturers, which comes from even like military technology and NASA technology, then we wouldn't have sort of the AI capabilities to look through a Raspberry Pi camera and detect faces, for example.
Yeah, or do certain behaviors based on what you see. I've got a drone that has some optical capabilities that when it's landing in particular, it knows how far away the ground is, and it slows down and plants itself beautifully every time.
That sounds like a DJI product, am I right?
Yeah, I got the Mini a couple of weeks ago, and I absolutely love it.
That's very nice. I stopped flying drones here as soon as they changed the regulations, so I now need authorization from Transport Canada to fly anything above 250 grams. And I mean, it's not difficult to do the course. I just haven't gotten around to it yet. So it's been a little while since I've been up in the air.
Well, the nice thing about the Mini is it weighs 249 grams.
Oh, they did it by purpose. That's the modern equivalent of the 9.9 horsepower outboard, I feel.
Yeah, exactly. But take a look at some of the videos on YouTube. You'll be absolutely amazed at the quality.
Oh, yeah. Again, everything shrinkifying and coming down in cost because of volume is insane. I don't know if you know anything about the advent of smartphones and what that brought to the electronics hobby, but I know that because of smartphones starting with the around the time that Apple had their first iPhone, and then there was an explosion of technology, that's what drove the gyroscopes down, the solid state gyroscopes down in cost. And now we can get them. I think I bought the last MEMS gyro board for like $1 or something.
Well, I can remember buying an accelerometer. This would have been probably in the early 90s, maybe a little bit after that, when I was working with the basic stamp. I was teaching a model rocketry course in the summer, and I developed a circuit where you could put the accelerometer in the nose cone of the rocket, have it record onto the what little bit of memory was in the basic stamp, and when you got it back, you could graph the acceleration curve, and also when the ejection charge went out and when it hit the ground.
Yeah, I mean, that sort of stuff is so impressive. And if the viewers want to learn a little bit more about it, I think Dave Jones from the EEV blog had a guest on where they were talking about how those gyros and those accelerometers work. They're capacitors, as far as I know. They're solid state capacitors, and the movement it just makes the plates approach and like get closer to each other and then move away from each other by, in the micrometer or less scale, and you can actually read that. It's incredible.
Yeah, and again, I was working with the first ones. Now you can get a 3-axis accelerometer that's the size of a grain of rice.
Oh yeah, and it's accessible to anybody. Do you know anything about Bruce Simpson's from RC Model Review's YouTube channel?
I do not.
So he got in trouble in the early aughts, somewhere like maybe 2006-7, something like that, because he had a website, not very different than yours, but he was doing mostly remote controlled aircraft and stuff, and he was writing a book about how to build a cruise missile at home, because the RC aircraft hobby, the electronics were coming down in price so quickly that anybody could afford a couple $100 worth of stuff, and you could build something akin to a cruise missile, without the warhead, just the electronics to steer it and stuff, for like a couple $1,000s, I think his bill of material was. So he had the FBI, he had like MI6, basically all the nations were starting to contact him, be like, are you a terrorist? Like, what's going on here? It was crazy.
Well, yeah, the GPS is really the thing that would drive that. They've gotten to the point now with these drones, the ones that don't have geofencing, you can put them through a door anywhere you want.
Oh yeah, it's super precise. And then for what you can't really do, because GPS still has maybe a foot or so of play in it, but then whenever you get that close, I mean, you have way better sensors for up close anyways, so you could do obstacle detection and avoiding locally. It's great. The GPS will get you within a couple feet, and then you can maneuver the rest of the way with other sensors. It's incredible.
Well, I'll tell you, the drone does a pretty good job, because if you tell it to come back to where it took off, it's within a few inches.
Inches?
Yeah, it's very, very precise.
That's awesome.
This one uses both the U.S. GPS satellites, and the Russian was a Glasnost. I'm not sure I'm pronouncing that right, but they've got a constellation of satellites also. This uses both of them.
Yeah, I guess the more points you can calculate from, the more accurate, right?
Correct.
So that's pretty awesome. But you and I have something else in common, is that so we both you used to teach, and I've just started teaching a couple of years ago. I think 3 or 4 years ago. It's hard for me to tell, because at some point when I was hired, there was a teacher's strike, so I don't know if they count that or not. But you taught math and science. What was your favorite thing to teach?
I enjoyed both of them. Probably science, because I built a lot of things and tried to bring some interest to it. We did a major unit on model rocketry every year, and it wasn't just building a rocket and going out and firing it on the football field, but it was all the tracking and determining the trigonometry so you could figure out how high it went, the acceleration, the top speed, all that. So it was probably 6 weeks of pretty intense study. There again are some phenomenal resources on the internet at that time in print that we made use of.
Yeah, absolutely. And I think having a teacher that is sort of into it, like really, not that, I mean, I don't want to say that you weren't there to do your job. You were obviously there to do your job, but when you take an interest beyond it, I think the students really latch on to that, and they start hanging on your every word a little bit more than just reciting whatever stuff is in the assigned textbook for the semester, right?
Well, yeah, and the advantage that I had at that time, this was in the early 70s, probably through the mid 80s. The principal that I worked under had confidence in what we were doing when we designed our own curriculum to meet objectives. Today, you're pretty much taking standard concepts that someone has put together in a particular order, and they want you to teach that. On Thursday, the 7th of April, you should be teaching this. Well, we didn't do that. We did, as I said, a big unit on model rocketry. We did another big unit on photography, and we would tie those things together with the concepts we were trying to teach.
Yeah, I teach college, so it's a little bit different than elementary, or I guess it's community college for you Americans listening. Over here, we have we don't call our universities colleges. I guess we have universities, colleges, and then that's it. Basically, a high school below that. So it's basically a trade school that I teach at. But I'm lucky that my boss and my direct supervisor, he's a co-professor there as well. He kind of he trusts me explicitly. It's actually, I was a little taken aback by how much he trusted me to deliver the content, even when I was like fresh. I was new. He just figured that I knew what I was talking about when it came to my profession, and that I would translate that on my own to the students. And then he got feedback from the students that I was doing a good job, I guess. And he's never doubted me. He's just gave me carte blanche to do whatever I want, which is great because I got to actually tinker with Arduino stuff and bring that in as an example where the Arduino would take the place of the vehicle's computer. Like one example I could give you is how automatic lighting works. You and I probably can think about it visually, but for the listeners out there, it's not trivial because you have to be able to measure the amount of light outside the vehicle, and then you have to go and make a decision whether that amount of light is enough that you don't need your headlights, or it's low enough that you should have your headlights, and then you have to go and switch on the headlights, which can also be activated manually by the driver, so you can't interrupt the driver's sort of wishes. So what I did is, when I came to that kind of unit, I was talking about how there's logic involved, because you can't just have a sensor sense light and then turn on the headlights whenever the light is dim and off whenever it's bright, because what happens when you drive underneath a street light? Your headlights would be flashing on and off all the way down the highway, right? So I actually built a small an Arduino type circuit that would actually wait until the light was constant enough to turn off the headlights, sort of like a security measure.
Well, there's an awful lot of thinking that has to go into programming beyond the fact that you have to know how to program.
Yeah, that's very true. There's a lot of considerations, and don't forget these manufacturers are under pressure to keep these cars safe. If something goes wrong, they're on the hook. You have to keep that in mind.
The hook for money, and also they may kill a few folks if they do it wrong.
100%, right? We have the famous case of GM and the ignition switches, right? Like they're I don't know if it was them specifically or if it was their subcontract where they contracted out the device, but the ignition switches were turning themselves off, and when your car's turned off, you have no ABS, you have no airbags, you have nothing, and so people died. I mean, it's a big deal.
Well, also the fact that today to start a car, you have to put your foot on the brake. That's been 20 years. And because of cars running away, getting out of control because of starting when you weren't ready for it.
Oh, 100%. Even the clutch safety switch, where if you have a manual vehicle, you have to have your foot on the clutch. I mean, I've worked on some cars from the earlier mid 80s. They didn't have that. So if you wanted to turn the car on and you had your foot on the brake, but it was still in first gear, that starter was moving you.
Yeah, you could use it to start the car.
Yeah, absolutely. Yeah, 100%. But speaking of cars, like, you have a video on your channel where you were showing off a nerd license plate, but I couldn't help but noticing what it was attached to.
Oh, my toy. That was a birthday present when I turned 70.
What is that? Something like 2017, 20-something?
That's a 14. Interesting story. I had had an opportunity to be in a car virtually identical to that when they came out in 2013 through 2014. And I fell in love with the color. It's a Laguna blue Corvette. And a couple years later, when I was ready to turn 70, this was 2 years ago, I decided I was going to buy one. I had a red Corvette at that time, and I wanted the blue convertible. And they no longer make that color, at least at that time, for Corvettes. And I found a used one that only had 270 miles on it. It had sat in a warehouse for 3 years. A dealership had ordered it and went bankrupt. And a local dealership bought it and was selling it as new, and I negotiated a pretty good deal, and I wound up with that one.
So that must be a nice toy to drive around in.
It's a little scary, believe me. It's 430. No, this one's 460 horsepower, I think. Yeah, it gets out of its way.
Is it the ZR1 version or just the sort of like the quote-unquote base model?
The Z51, which is not a ZR1 or a Z06, but it has everything that those have except for the supercharger. So it has the 20-inch wheels on the front and 21 in the back, or 19 and 20, forget which. It has the fancy red calipers with multiple pistons and a little wing on the back. It's very nice.
It's a convertible, right? I think so. Yeah, convertible.
Correct.
But tell us a little bit about the license plate then. So you have a license plate. Basically, the video was framed as though it was a challenge to figure out the meaning of the license plate. And for the viewers, the license plate read 100101.
Yeah, I've been a math teacher and kind of fascinated by mathematics all my life. And 100101 is binary for 73. And that's of significance because if you watch The Big Bang Theory, 73 is Sheldon's favorite number. And when I decided I wanted to get that license plate, I was surprised it was available in Pennsylvania, first of all. And the other thing, the reason 73 is his favorite number, you can look it up, but 73 is a prime. If you reverse it and get 37, that's a prime. If you take the prime factorization of this and that, and there's a ton of things that he has. But what he missed, I mentioned I'm a ham radio operator, and if you are ending a conversation, the way to give greetings is to say 73s. So it fit into my ham radio hobby, it fit into my enjoying The Big Bang Theory, and it fit into me enjoying binary. And it is a palindrome. That's the other thing that's important. Reads the same in both directions.
So once again, something else about you that is just absolutely elegant, right? It just seems to, this one thing seems to cover a lot of possibilities. So that's number 2 on this podcast, between the solution for the thunder and lightning and the license plate.
Every once in a while I get it right. Yeah, the big one on YouTube was the fidget spinner brushless motor. I did that about 3 years ago just on a whim. I had been in New York City and the street vendors were all selling these little fidget spinners and I had to buy one. And then once I bought it, I couldn't figure out what to do with it. And that's when I decided to turn it into a motor.
Yeah, that video is fantastic because, and we spoke about this a little bit before the recording here, but it is such a great way to introduce so many different kind of topics, and in a way that a beginner can do it. In fact, I've been planning on, I think I'm looking over at my workbench here. I think I have magnet wire sitting there for the last 3-4 years, I guess 3 years, waiting to build myself my own version of that, but I just haven't got to it yet. So tell us about the process of building a brushless motor with a fidget spinner.
Well, it's just a matter of, a brushless motor does not have any electricity going to the turning part of the motor. It's just got permanent magnets on it. And whereas a brushed motor has a powered armature, and there's a commutator and a bunch of other things that complicate it. And this one, I just took the 3 lobes of a common fidget spinner, put magnets onto those lobes, and put electromagnets that could be turned on and off based on the position of the fidget spinner. And every time it went around, there was a little boost from an electromagnet that attracted or repelled the permanent magnets. I think I got it up to 5,000 RPM at one point. There's a 3rd or 4th video that deals with that. But I just had a whole bunch of different ways of triggering the electromagnets, positioning the electromagnets. And while we're on this, I need to mention probably my favorite tool of all time. I was fortunate enough to make the decision to buy a laser cutter about 5 or 6 years ago. And that enabled me to do just a ton of things. And on that project, if I could conceive of a particular mount, I would design it in CorelDRAW, send it to the laser printer, or laser cutter rather, and in a couple of minutes I would have the part that I needed.
What kind of laser cutter is it?
I've had three. I still have two of them remaining. The first one was a what they typically call a China blue laser cutter, which was less than $400 on eBay delivered, and it was somewhat limited. It was a crude machine. I sold it for pretty much what I paid for it, and bought the next iteration, which was about a $1,500 China blue, much more powerful, much better designed and built. And I also bought a Glowforge, which was a startup a couple years ago. I think I waited 2 years for delivery, but it's an elegant, beautiful, you can put it in your living room type piece of artwork. And I have those two, the big one that I got from eBay and the Glowforge. They're a little bit different in what they do, but the end result is about the same. But I got rid of my milling machine. I got rid of my lathe. I don't need them anymore. I can use this.
Yeah, but you have to, I feel like you need a little bit of a different mindset to work with something like a laser cutter, because you kind of have to think in 2D and sort of like assemble it into a 3D part, correct?
That's correct. I have two 3D printers, but to be honest with you, I'm nowhere near as good with the 3D software as I am with the 2D software. As I said, I use CorelDRAW. I've been using that since version 1 back in probably the 90s. And I can do a much better job of expanding two-dimensional things into a three-dimensional thing than I can to generate the three-dimensional things that the 3D printer needs from scratch.
Yeah, I'm learning 3D modeling. I just, my viewers don't know this yet because I haven't published a video, but I just designed like a sort of a computer fan holder to go over a power supply, so it quiets down my 12-volt power supply. And it's really, if you ever get into 3D modeling, it's really thinking in 2D first, and then you're kind of like extruding from 2D. So you kind of like build your sketch in 2D as if everything is stacked on top of each other, and then you like drag portions of the sketch upwards, and then you cut holes by drawing 2D sketches on like the side of what you've extruded, and then you like extrude it through the shape. So I think a little bit of your 2D knowledge will translate to 3D. And if you're ever looking for free software, I think Autodesk allows you to use Fusion 360 for free as long as you use it for non-commercial or startup or personal purposes. So that's a good place to start.
Yeah, I've used a number of different packages, starting out with SketchUp. It's also slow.
Oh, yeah.
If you want something that's intricate and reasonably large, it's easily an overnight job, and in the middle of the overnight job, it could fail, and you wind up with a pile of string all over the place when you wake up in the morning.
Knock on wood, I have not yet got that situation, but hanging out in the 3D printer subreddits, there's definitely potential there. Do you frequent Reddit at all?
I do not.
It's an interesting place. I would say if you've made it this far without it, you'd probably be good to stay away from it. But it's simultaneously the best and the worst place on the entire internet. So if you stick to the communities that you know, like for example, the ham radio hobbyists or the model railroad hobbyists, if you go into those communities, which are called subreddits, so it's like sub forums basically, those places you'll trust me, you'll be at home. But then there's also like Reddit is the seedy corner of the internet as well. So it kind of depends on which communities you go visit.
Yeah, there are a lot of things on the internet that for whatever reason I've never embraced. I don't pay much attention to Twitter. I don't pay any attention to Facebook. Primarily, I'm a web-based person, YouTube-based person. That's more than enough to keep me busy.
Yeah, speaking of your web-based stuff, so not only are you great at building physical things and physical concepts and laser cutting, but you also design your own websites. Like you're very public about the websites that you own and operate, and anybody can go take a look at them, and that's all written from scratch, really.
Well, with a little bit of help from an old program called Front Page, but yes, I mean, I've done web pages strictly in HTML. I know my daughter learned it that way. When you go back far enough, that was I can remember the internet before there was any HTML. It was strictly text. If you looked for a weather forecast, you typed in an IP address and you got back a text statement that told you what the weather was going to be.
Yeah, absolutely. And what's funny about all that is that I have a WordPress website, which I will say looks more modern than your websites. I won't say more responsive because I think having a little bit more front end load actually makes websites a little bit slower. And although WordPress, they really would like everyone to think that they're super fast and responsive, they're not as fast as a text-based website, that's for sure. But if you go and edit the pieces of the website manually, it's still all written in HTML and PHP and a couple other little things. But I mean, it's all still there. We still use it.
And speaking of which, you can have a web server with a Pi Zero.
You can, in fact, absolutely. You can run a web server for just yourself, or you can serve it to the general public. I mean, your ISP might have some issues with random traffic coming onto your home network, but the Pi is perfectly capable of serving a simple website. Absolutely.
Yeah, one of the other projects that I had published, it was in Make magazine, again, some years ago, about 5 or 10 years ago, was a video switcher that I'm still using that puts the video from 3 or 4 security cameras onto the internet, and I serve that from my house. My ISP doesn't care what I do, with uploads. And I can check and see if people are in the driveway or if the mail's at the front door from literally anywhere on the planet, or I suppose in orbit.
Yeah, absolutely. I'm sure Chris Hadfield would have logged in if you would have asked him nicely enough. That guy seemed pretty well connected.
Yeah.
He's kind of like my Canadian representative to the world of space, because he's a Canadian astronaut.
Okay.
I mean, you have to admit, most of them up at the ISS are Americans, so I gotta take what I can get, and I'm glad that Chris Hadfield was my representative, because he seems like an upstanding guy.
That's what you need. I tell you what, we shouldn't talk politics.
No, for sure. You're right though. It's easy to these days it's easy to change any topic into politics, right?
Indeed. One other thing I wanted to mention about the laser cutter, and folks, if they're interested, can find this on my trainelectronics.com website. I put together a Mr. Rogers trolley, scratch built. I built a couple of them for a layout that we have at Pittsburgh's Children's Hospital. And I got permission from the Mr. Rogers people to do that, because that's a copyrighted image. And I built them with basically brass for the railings, and I carved maple for the roof and the clear story and all that. I decided at one point that I would like to make an entire trolley with the laser cutter. And you talk about taking something that is two-dimensional and turning it into a three-dimensional object. I've been very pleased with how it turned out. So if you go to the website and look for laser cut trolley, I did everything: the railings, the benches, the roof, the clear story, the front, the base, everything with a laser cutter, and it turned out beautifully. I'm very, very pleased with the way that went.
I saw that, and it's actually incredibly impressive. And I mean, I guess it's not really, you're not really limited by your tools. You're really limited by your creativity. Laser cutters have come down in cost far enough, and 3D printers for that matter, that if you can dream it, and if you can figure out how to segment it into its base components, you could build anything. You could literally build anything, right?
Pretty much. And I've been fortunate that my brain seems to work pretty well when it comes to figuring out puzzles.
Yeah, it does. You touched on an important point, because if you're out there listening to this and you're finding that the software or drawing something that will cut properly on a laser cutter, or the software for CAD is not intuitive to you, it's very possible it's just the way you think, the way you've learned to think. And I'll tell you, even though it might be a little bit more difficult for you, if you stick to it, it will click, I promise. It just takes a little bit of practice. And we all learn at different rates, but I guarantee you can do it. Anybody can do this. It just takes a little bit of practice.
Yeah, you stick with it. I mean, when I had to learn Morse code to get my ham radio license, that was tedious. It took me weeks and weeks of study. Eventually, I got to the point where I was able to do it. The same thing with a computer language. I mean, I knew nothing about C when I started working with the Arduino, but stuck with it, did a lot of tests, a lot of experiments to see what would happen if I changed this, a lot of tracking down error messages, which I think in the Arduino front end are pretty short as a rule.
Yeah, and generic.
Hard to squish. But yeah, you can do it. Just spend time. Also, walk away from it periodically. If you get stumped, take a break for a day or two, and you'll be surprised what you come back to.
That has its basis in psychology. It takes a little bit for new skills to crystallize itself in our brains, and sometimes walking away from it is what you have to do in order to crystallize that knowledge, right? In order to make it real.
I always like to think my brain's working in the background.
Yep. I mean, yeah, absolutely. We all have background processes at least, right?
I would hope so.
So you've mentioned in multiple of your videos, and once now in this podcast, that you did some work for the Children's Hospital, and being that you're a model railroad enthusiast, I guess that puts you in a unique spot to bring joy to kids at the Children's Hospital. Do you want to talk to us a little bit about what you did for them?
Yeah, about 10 or 11 years ago, they built a new children's hospital. They actually wrapped it around an existing hospital and moved it from one part of the city to this new location. And we had a model railroad layout at the original children's hospital that had been there probably 15 years. And they wanted us to expand it. So we wound up designing a 12 by 18 layout that had the Mr. Rogers trolley running on a trestle on a point-to-point into a mountain, and another train that ran on the ground. I designed all of the controls for that so that when you push a button, it would run for a certain period of time. And I also designed about 8 different animation or sound effects that went with that. There's an elephant that makes his trumpeting noise and lifts his trunk up. There's little prairie dogs that pop out of the ground when you push another button. There are kids on playground equipment that spin around when you push another one. There's a ballerina that gets flipped around a bar on another one. It was a lot of fun, and I've been fortunate that I've been able to go out there periodically and maintain everything, because it's one of those deals where I build it, I'm the guy that knows how to fix it, and it's been quite reliable. So we have that layout, and there's a Harry Potter train layout that was donated to the hospital. I maintain that one too. So it's a lot of fun.
You mentioned that you're in your 70s. Sorry to underline it for you again, but how does it feel to have something that's a hobby of yours when you're in your 70s, and probably it was when you were a kid too, but how does it feel to have a child come up to the layout, look at the layout, and smile, and knowing that that's maybe the only smile that kid had that day or that week? How does that make you feel?
Oh, it's wonderful. It really is. I'll sit back sometimes and just watch the kids push the buttons, and for the first time, it's really fascinating to see them connect pushing that button with some sort of animation that takes place. Unfortunately, most of the time when I go to visit, I'll go at 4:30 or 5 o'clock in the morning, because there's nobody there. And if I'm going to be doing some soldering, or I'm going to be opening a door into the layout, because they're all obviously protected by plexiglass, you don't want kids around, and I don't get to see them as often as I could. But I do get feedback from the staff, and that helps a lot.
Absolutely. I think if I had a skill that could make a real difference like that, I think I would be inclined to do it. In fact, I probably do have a skill that that could help people. I wouldn't know how to apply it at this very time. But it's very noble of you to apply your knowledge to making someone's day brighter. I think that's just fantastic.
Well, the other thing that I do with model railroading that has something of an impact on kids is once this virus thing is over, we generally set up a modular HO railroad in various communities around Christmas so that kids can come and see the trains and enjoy them. So I don't know how soon we'll be doing that again because it's a fairly busy indoor venue. But when that happens again, hopefully we'll be able to set the railroads up.
We have an incredible science museum here in Ottawa, the Ottawa Science and Tech Museum. It's world famous for having like a crooked kitchen. It's a kitchen that messes with your kind of perception of depth and stuff like that. It's actually built on a slant and makes people woozy just looking inside. But what makes this museum unique to me is that they have 4 or 5 full-size locomotives indoors that you can walk around. You can there's like paths so you can go into the actual where the conductor would be and stuff like that. And I think they're all from the coal-powered steam engine days. It is incredible to see a young child who probably doesn't have a concept of trains beyond like cartoons and stuff, because it's just simply not that common of a mode of transportation here, and look up and feel like an ant next to these things that are absolutely giant. So I can just imagine like seeing a model railroad layout would probably give like a very similar impression, like, wow, this is how they run. Look at them. They can go behind like in these tunnels and stuff. Like it's incredible. It just, it must be incredible.
Lots of fun. That's the objective. When you retire, you have to have lots of hobbies so you have lots of fun.
Yeah, I feel at my age, I don't think retirement will be a concept by the time I'm in my mid-60s, late 60s. But I feel like I'm just going to, I'm going to die doing YouTube, basically. I don't think I'm ever going to stop this part of it. This is the part I choose to do,
Well, YouTube's an amazing tool. I absolutely love it. And unfortunately, during all of this virus stuff, the pandemic, I haven't been as motivated to do videos as I once was. I'm doing other things, playing around with drones and ham radio equipment and riding bikes, but I'll get back to it.
Yeah, I would encourage you. If I could give you any words of encouragement, I think that your latest video, when it came out, I was excited. That was the first video I clicked on, because it's been a little bit like since you've posted something, for sure.
Yeah, it's been months, actually. I have a number of things that I could put on there, but it's kind of like Groundhog Day, the movie. The routines are all screwed up and you just do the same thing over and over again.
Yeah, that's true. Have you ever thought of doing more tutorially, like basics sort of videos, like teaching people the basics of electron flow and resistance and current and stuff like that?
I've thought about it and rejected it because that's not my strength. I mean, I could do it, but there are a lot of other people that do it as well or better than I would. I would rather do something that is not necessarily unique, but at least not common.
That is definitely the feeling I get from your channel. I just know you have all those years of teaching experience, and a lot of people, all they need is a different voice, right? Sometimes they listen to one video and it doesn't click for them, and then somebody else will say it in a slightly different way, and it'll just jive with them, right?
Yeah, that's a possibility, but I still have other things to cover first.
Fair enough, and I'm excited to see what the future holds for your YouTube channel. That's for sure. So for the previous guests I've had on, I've gave them all the exact same question towards the end of the podcast here. So this question has a little bit of a setup, but the setup is that you get a government grant, and the point of me saying government just means that let's say it's a semi-unlimited source of funds for you. But you get an unlimited a government grant to start the business of your dreams. So profitability is not really a concern in this question, but it does have to provide a service or a product or something like that. So you get a grant to start a business. What kind of business do you start?
Boy, that's an interesting question. Uh, I think I would lean towards something that had to do with maybe a laser cutting business. I really enjoy putting things together and having them come out of the laser cutter, put them together, have them, take something that was just an idea and turn it into a physical object. So maybe a laser cutting service, whether I would do something for other people or train them in how to do it so that they could create their own things, teach them how to use it.
That's a very cool idea, actually. I love the training aspect. I've actually, I'm starting a small business this year. Hopefully this year, yeah, we'll see. Training people, basically what I do at the college, but training technicians in their workspaces, really. And so I think I love the idea of training. And I think for myself, I don't have a laser cutter, and if I had a way to learn how to use one beforehand, like some sort of service like that, I think that would be something I would take advantage of.
Yeah, we have a couple of maker spaces in Pittsburgh that give you access to such things, but they fell on hard times as well, and I'm not even sure that they're in operation anymore, but that was the type of service that they would provide.
Yeah, that's awesome. My public library has a laser cutter, but it's all the way across town, and you have to rent time. But I think they don't give you support. They just, you have the computer attached to it. You get your files from the internet, and you put your material in and run it. I don't think they have a technician there. And so I kind of worry about when this virus is over, what state of repair it's in when I go to give it a shot.
Yeah, they do have to be maintained and kept aligned for sure. Otherwise, they're not worth much.
And I think I was reading that the smoke can often cloud the mirrors, and if the mirrors get a little bit dirty, then they start burning because they're not reflecting anymore.
Yeah, you have to clean them periodically. I do tear mine down, but I've got powered exhaust fans on both of them that do a pretty good job of removing the smoke. And there's also a positive pressure. There's a blower, if you will, that forces air through the nozzle and keeps it away from the primary lens, and also blows debris away from the area that's cutting.
Well, that's useful. I was suggested to look at a laser cutter called the K40, and I think it's the new sort of generation China Blue type thing, but it's still like $700 Canadian. So I might get one, but at the moment, the YouTube channel is definitely a money sink and not a money generator. So maybe in the future, we'll see.
Yeah, well, hopefully that the YouTube will take care of the need to buy stuff like that. That would be nice.
It would be nice, yeah, absolutely.
Yeah, I've never monetized my YouTube channel simply because it's not a big priority for me right now, and I don't like to bother people with a whole bunch of ads if I can avoid it.
Yeah, I'm looking at the stats, and most people run an ad blocker, and I don't blame them because some of the ads are just absolutely horrendous. Like when I watch my friends' YouTube channels, I don't have an ad blocker because I'm typically in bed on my phone, and yeah, sometimes I get like two ads for a mobile game in a row, and I mean, if I'm being honest, I don't even own a mobile game on my phone. I don't have any apps that are games, so why would Google think that I'd be interested in that? But I guess it is what it is.
Or if you make the mistake of searching Amazon for some particular product, you'll get ads for the next 2 or 3 weeks.
Absolutely. Or if it's not a problem for me because I don't have Facebook, and I haven't had Facebook for a very long time. But like my parents, for example, they use Facebook often. If they have the app on their phone and they have a conversation about something searchable, that becomes their ads. Like there's no hiding the fact that Facebook is listening to whatever's going on.
Yeah, for sure. I'm looking over a list of things here that I wanted to cover, and I think I've hit most of them. Do you have any questions?
No, I think actually I'm getting close to the end myself. But the biggest thing is where can listeners to this podcast interact with you? Do you just want them to go to the comments section of your YouTube channel, or do you want them to go to your website? What's the best place?
You can go to my website, either trainelectronics.com or davebodnar.com. My email is on there. You can send me an email if you have questions about something. You can put comments on the YouTube channel. You're probably aware, but if you put a comment on the YouTube channel, I get an email immediately saying, hey, there's a new comment about fidget spinner or whatever. So whatever works for you. I'm pretty much an open book as far as getting in touch.
You guys should definitely take a look at what Dave has, at least on YouTube, but his website is just a dearth of knowledge as well. I would highly recommend you check out his stuff. Every single one of his published videos are interesting, so go take a look. And Dave, I want to thank you so much for dedicating some time to speak to me and kind of let the viewers know who you are.
It's been my pleasure. Time went quickly.
It did. And I want to thank all of you listeners out there for listening, and I hope to catch you in the next one. Have a good one.
Bye-bye.